Hey everyone, and welcome. Today, we're diving into a fascinating intersection, the philosophical ideas of Gilles Deleuze and Félix Guattari, and the surprising world of mathematics. Specifically, we're going to explore how their concept of the rhizome finds echoes in some pretty cutting-edge mathematical fields. Now, if you've encountered Deleuze and Guattari before, you know their work can be challenging. But don't worry, we'll break it down. At the heart of their philosophy is this idea of the rhizome. Think of a ginger root, or a network of fungal mycelium. Unlike a tree with its single trunk and hierarchical branches, a rhizome is a sprawling, interconnected network. It grows in all directions, has no central point, and any point can connect to any other point. It's non-hierarchical, decentered, and constantly evolving. It resists being boxed in, categorized neatly. Deleuze and Guattari used the rhizome as a metaphor for thinking, for knowledge, for social structures, basically, for everything. They argued that traditional, Western thought, much like that tree, tends to be arborescent. It's all about hierarchies, binaries, and finding the single, central root of things. Think of the classic Cartesian plane x and y-axis, everything neat and orderly. But what if we approached mathematics itself rhizomatically? What if we moved beyond the linear, the predictable, the Cartesian? That's where things get really interesting. Let's start with something called topology. Topology is sometimes called rubber sheet geometry. It's less concerned with precise measurements and more about the relationships between points and spaces. Think of a coffee cup and a donut. Topologically speaking, they are the same. You can deform one into the other without tearing or gluing. This kind of thinking, focusing on connectivity and deformation rather than rigid structure, is inherently rhizomatic. It breaks free from the limitations of Euclidean space. Then there's network science. This field studies complex systems, from the internet to social networks to, yes, even biological rhizomes. Network science is all about mapping connections, understanding how information flows, and identifying emergent properties that arise from the interactions of many individual parts. There's no central control node in a complex network. The behavior emerges from the multiplicity of connections. Sound familiar? Now, let's get a little more abstract. We're going to touch on category theory. This is a very high-level branch of mathematics that deals with, well, categories of mathematical objects and the relationships between them. Think of it as a mathematics of mathematics. Instead of focusing on individual objects, like numbers or sets, category theory looks at the morphisms, the arrows, the transformations that connect them. It's all about the processes, the becoming, rather than the static things. This emphasis on relationships and transformations, on the flow between different mathematical structures, resonates deeply with Deleuze and Guattari's concept of difference and becoming. The differential in differential calculus, or the antiderivative in integral calculus, are all about how things flow and transform into something else. So, what's the takeaway? Deleuze and Guattari weren't mathematicians, but their philosophical insights about nonlinear thinking, about interconnectedness, about escaping rigid structures, find surprising parallels in these advanced mathematical fields. These mathematical concepts aren't just tools, they are ways of thinking differently. They challenge us to move beyond the limitations of traditional, hierarchical, arborescent models, and to embrace the complexity and dynamism of the rhizome. They suggest that even in the seemingly abstract world of mathematics, there's room for a more fluid, more interconnected, more rhizomatic understanding. What do you think? Are there other areas of mathematics that embody this rhizomatic spirit? Let me know in the comments below. And if you enjoyed this exploration of the unexpected connections between philosophy and math, be sure to like this video and subscribe for more. Thanks for watching.